equation. So we just need to check whether the linear system A is equal W is consistent. Say one with the German matrix. Say 2. Go reduction elimination. Say 3. Simple rows not lay row 2 equal row 3 means they are dependent. No contradiction appears. Notice that row 2 equal row 3 means they are dependent. No contradiction appears, therefore check for consistency. There is no row of the from 0, 0, 0, 10, 0. So the system is consistent since the adjournment matrix has no contradiction.
To determine if a vector is in known space, we need to check if a matrix vector multiplication AU equals to the 0 vector. If AU equal to 0, then U is in the known space. If it doesn't, it is not. To perform the multiplication step by step, we step up the matrix A multiplied by the vector U. For the first entry of the resulting vector, we take the dot product of the first row of A and the vector U. That gives us 1 times 5 plus negative 3 times 3 plus negative 2 times negative 4. Simplify this, we get 5 minus 9 plus 4, which equals to 0. Next, for the second entry, we take the dot product of the second row of A and the vector U. This gives us negative 5 times 5 plus 9 times 3 plus 1 times negative 2. This simplifies to the negative 25 plus 27 minus 2, which also equal to 0. Since both entries are 0, the product AU is indeed the 0 vector. Therefore, we can confidently conclude that the vector U is in the known space of A.
And here's exercise 13. And we have matrix A, and we have to find the values of H in vector U. And vector U belongs to null A, so A times U should be 0. And we go to the matrix calculus. We can get 12 plus 6H minus 4 minus 2H and 8 plus 4H 3 rows, and it should equals to 0, so equal to 0 matrix, and so that we can get H equals minus 2.
Exercise 14. Find a spanning set for non-A. So the first step is to let AX equal to 0. And the second step is use the row operation to let A become reduced row echelon form. So after the row operation, we can see that column 1 and column 3 have a PV number. So we can know that x1 and x3 is a basic variable. x2, x4, x5 is a free variable. So we can translate the reduced row echelon form back into a system or equation. The first one is x1 minus 2x2 minus x4 plus 3x5 equal to 0. And the second one is x3 plus 2x4 minus 2x5 equal to 0. And the next step is to isolate the basic variable in terms of the free variable. So the first one, x1 equal to 2x2 plus x4 minus 3x5. And the second one is x3 equal to minus 2x4 plus 2x5. And after finish this, we can see that the spanning set for non-A is here, like this.
Exercise 15. Find a spanning set for non-B. That means that we need to solve the equation bx equal to 0. And from the matrix, we get two equations. The first equation is x1 plus 4x3 equal to 0. The second equation is negative 2x3 plus x4 equal to 0. So x1 equal to negative 4x3 and x4 equal to 2x3. And here we know x2 and x3 are free variables. Therefore, the solution vector can be written as this. And now we separate the free variable can get this. And therefore the spanning set for non-B is the vector 0, 1, 0, 0 and the vector negative 2, 0, 1 over 2, 1.